Hello fellows, Herogon here. December 2024 was something decent, albeit bittersweet. We are about to enter or have entered a whole new year where I've retired coverage of Shawn LeBro's fighting game framework, and I'm close to getting my associate's degree in game development at Full Sail University. I must admit, over the past 2 or 3 years, I've handled covering the fighting game framework from Shawn LeBro. I've embraced what he has done for the game development community. However, for me, all good things can and should have an end point for one chapter. My new chapter of doing my own thing while still watching Shawn LeBro's tutorials without worrying about making a Funlog covering a month's worth of that sounds good to me. With all that said, let's jump into this final fighting game framework, Funlog. On the first day of December, our friend Shawn gave to thee a data structure for in-game trophies. This involved using a data table to fill out info for each challenge and displaying these unlockable achievements in a profile menu. We all love getting achievements, don't we? Whether we're playing on PlayStation, Xbox, Steam, or anything else we enjoy, you gain some kind of reward out of things. Does getting all 40 trophies in Sonic X Shadow Generations answer your questions about my efforts and achievements? Anyway, let's get to the logic bit. In base game instance.h, we've created a new data structure known as achievement. It is a public table with 4 different variables. We have 2 text variables called name and description, as well as 2 more that are uTexture2D variables called icon and background. While this may sound small, you'd be surprised at how it can help compared to manually creating hundreds of achievement tiles every time. Going to the blueprints, we start with the achievement list widget. In there, we have temporary logic that will visualize our achievement data. We get data table row, with the data table being achievement data and our row being 0. Then we break our output data and set our respective variables to equal the data values we put in. The target will be our achievement tiles within achievement list, with update achievement info as the last part of our logic. We repeat the same stuff for any other achievement tile widgets in achievement list. Much of our pre-existing logic remains in achievement tile, but now we have a custom event going into the logic, so we can call one named update achievement info as a function in achievement list. As simple as the logic for that week was with achievements, I know we'll be coming back for another round someday. And just like getting achievements in games, that should be its own sweet reward. On the 8th day of December, our friend Shawn gave to thee a camera that works with tag teams. This involved replacing the player 1 and player 2 ref variables, using the active team 1 and active team 2 character variables as the new required part. Much of the work was done in the base camera blueprint, renamed from the default camera. First, in use camera, the custom event that we have, we set our game mode reference variable by casting to default game mode blueprint. After that, we go through all of our functions and logic to replace any player 1 and player 2 ref variables with validated get active team 1 and active team 2 character variable nodes. While it may take a while to do everything, using these validated gets for the new variables are important. That week proved another decent time, as there wasn't much issue with the new logic. Things worked as they were, if not better than before. However, the 15th day of December would be when things took a different turn. On the 15th day of December, our friend Shawn gave to thee the start of a code class camera indeed. This involved transferring over almost every bit of logic and function from our base camera blueprint. Functions such as determine if camera should move, and variables like is team 1 character on left have all been put into code, which looks quite different from how the blueprints visualize logic. For example, in Tick, there was plenty of logic already for blueprints. However, when translated into C++ code, the results look quite different. In the base camera.cpp, we have a tick function that was translated. First, we get our parent tick function before checking if our game mode, active team 1, and active team 2 characters all are valid. Then we determine how close the camera is to the characters by subtracting the variable offset x-axis from our active team 1 character's location. We must also determine the sums and averages of our characters' y and z-axis locations. For the sum, we add both active team 1 and active team 2 characters' locations on a certain axis. With the average amount, we multiply by 0.5, which is also dividing by half in another way. If we have not set our camera bounds, we set the minimum camera height to the average z-axis variable and has set camera bounds to true. Next, we do another check using the Boolean function determine if camera should move with an input of float variable average y. That Boolean function will check if the new camera y location input is greater than the left max variable and less than the right max variable. If the value is true, from there we first set our actor location to a calculated location variable. This variable uses an f vector with inputs camera x, average y, and a clamp with average z, min camera height, and max camera height. We then adjust the field of view for our camera, which will require another float variable first. Dist y subtracts active Team 2 character's y-axis location from active Team 1 character's y-axis location. The current field of view equals a clamped value with inputs of an absolute value of dist y times the field of view modifier, min field of view as another part of the input, and max field of view as another separate part of the inputs. Finally, we get our camera component and set the field of view to whatever value our current field of view is. Otherwise, if we should not move our camera, calculated location will instead be using the inputs of actor locations x and y axes, while the z-axis value will use a clamp of average z, min camera height, and max camera height. Even though our code camera is not ready for full use yet, I believe the transfer to C++ code could be beneficial to how the fighting game framework is optimized. After all, who knows what the future holds for the implementation process. On the 22nd day of December, our friend Shawn gave to thee a code class for our stage boundaries. That week's tutorial covered transitioning the stage boundary and camera edges from blueprint to code, and further improvements to our camera class created with C++ in the last week from December 15th, 2024. First, we create a new code class called Base Camera Edge. Once again, a lot of blueprint logic was translated into code from the box collision component and static mesh to the on component hit. In base camera edge.h, we've added one function and two components. The two components are exactly the same as what we had in blueprints: a box component and a static mesh component. For the function, we call it hitBox collision, used when the box collision component collides with another object. It has a few inputs involving components and actors, as well as a normal impulse vector and hit result input. In the .cpp, we call hitbox collision in the begin play function, using box collision component to call on component hit .add dynamic. Within the hitbox collision function, we check if our character is the other actor we're hitting. To call our character code, we need to add an include line. If everything is valid, we go to check if the character's combo state is equal to launched. Before we continue, we have created a get and a set function in the character code for combo state. That way, we can access any private variables. For getting the combo state, we return the combo state variable. Meanwhile, setComboState sets the combo state to equal the input of eComboState_state. Going back to the hitbox collision function, we check if the player is facing right by using another getter function, this time called getIsFacingRight. If this particular thing is true, then we use the custom launch character function, where we pass an F vector with the values of 800.0F on the y-axis and 100.0F on the z-axis. Otherwise, we do the exact same custom launch function stuff, but instead use negative 800.0F for the y-axis value input. Finally, outside of that, we set the combo state to wall bounce and set ignore player-to-player collision as true. While this was a lot to go through, you might notice that we're getting closer to bringing all of our camera blueprint logic over to code, which could optimize the performance. Once I completed that video of the week, I looked forward to seeing what the next step was for the camera code. For now, at that very moment, however, I would have to wait. On the 29th day of December, our friend Shawn gave to the more code-based camera. That week, the Camera Blueprints Use Camera Custom event was translated to C++ code as a function in the base camera code class. Even though this was one of the last videos from Shawn the Bro released in 2024, I am sure that the code-based camera will still be improved beyond 2024 and into 2025. Before checking out the base camera code class, we changed the name of one function in base camera edge. In this code class, we renamed hitbox collision to onHitbox collision, which should give better context to when our function happens, which is when the box collision component collides with another object. Going to base camera, we have added a new function called useCamera. This is where we translate our useCamera custom event from the blueprint logic into C++ code. First, we check if we're getting our player controller as a target with player index 0. We'll then set view target with blend to the player controller using a reference to itself, known in code as this. The next part of the useCamera function is spawning our camera edges. To do that, however, we need to reference the base camera edge code class and create variables. In the base camera.h file, we've created 6 different camera edge variables to reference inner and outer edges. However, to ensure we can call base camera edge in base camera, we should add an include line above our generated .h file. Once that's right as rain, we can now set these camera edge values in .cpp. By default, they are null pointer or null PTR, but in useCamera, we get world and spawn our base camera edge actor as our equal value. The inputs for spawning this actor for Camera Edge, will be getting our actor location and rotation. While the next tutorials involving camera coding will be to translate our set inner boundaries function, this is currently great progress. As this video is released, we've reached Shawn the Bro's last tutorial of 2024 before 2025 will bring in new tutorials to watch. Even if I take the operations into the background instead of the forefront with YouTube videos, you can be rest assured that I'm working and going like any busybody or busy buzzing bee would. Overall, December was an easy time for the tutorials, though the holidays can bring some tough times with scheduling. I know not everyone can remain merry and bright throughout the month, but I do hope you've had yourselves a merry little holiday or holidays coming your way. The new year might not be an easy transition, but we can all try our best to look forward to new horizons. I know I'm going to try my best as I continue my Full Sail University journey to getting an associate's and then moving towards a bachelor's degree. Credit goes to Shawn the Bro for all his tutorial work, which I've enjoyed going through over the past few years and more to come. It has been a lovely backbone for my fighting game framework Funlog content, and I'm thankful for all Shawn has done to educate budding Unreal Engine users. I hope I can succeed as he has when working with Unreal Engine, and I hope I can live up to his alma mater's name, that being Full Sail University. And to all my viewers, I want to thank you for watching my content and sticking with me for this long, through thick and thin. Whether you came in when I first created my YouTube channel, or you were someone that came in from the Instagram account that I have, or even coming in right now, thank you. While this chapter of my life is changing, I want you all to remember the good times while also moving forward to bigger things. I have a feeling I'll be moving on to bigger projects, but the question might be, will you take that same plunge? With all that said, I hope you like this video. So comment, like, and subscribe below if you have not already. It helps plenty of YouTubers out, especially in tough times like these. I've been Herogon, and you've been your amazing, brilliant, ever-loving you. Thank you for tuning in, everyone, and I will see you all next game.